The Complete Guide to Electronic Basics and How to Get Started Arduino Project. Introduction. I will introduce you to the Complete Guide to Electronic Basics and How to Get Started with an Arduino Project. I will also present you some practical tips on making your electronics work correctly. Electronic devices are everywhere in our lives. They can be found in everything from our cars, computers, televisions, Arduino board, and even the light switches in our homes. Electronics are a crucial component of modern life because they can do so much for us. For example, they allow us to make phone calls or send text messages without using a dialing device or a phone line. They also allow us to connect using various social media websites like Twitter and Facebook. The Arduino platform is the perfect way to get started with electronics and programming. It is so easy to use, and you can build your projects with it. The Arduino has a wide range of components that can be used in your projects, including sensors, motors, lights, displays, buttons, etc. What are electronic basics? Electronic basics are the most fundamental concepts of electronics. It is the foundation for understanding how electronic devices work. This section will allow you to learn about these critical concepts, focusing on analog and digital electronics. What should I know about analog and digital electronics? Analog and digital electronics are two different electronic circuits that use different methods to signal information. Analog signals can be continuous or discrete, while digital signals are always binary 0 or 1. Analog signals represent continuous values, while binary signals represent a range of values between 0 and 1. The difference between these two signals is that analog circuits use voltage levels to change state, while binary circuits use logic gates instead of voltage levels. Voltage and current concept. This is an introduction to the two concepts of voltage and current. Voltage is the name given to the difference in electrical potential between 2 points. Voltage can be measured by a voltmeter, which can measure the difference in electrical potential. Current is the flow or charge of electricity through a conductor, such as a wire or an electric circuit. Current can also be measured using ammeters and amperes, which are units that express how much charge flows via a conductor in 1 second amperes or 1 minute ammeters. Voltage concept. The voltage concept is a way to measure the potential difference between 2 points in an electrical circuit. It represents the amount of work that can be done when current flows through a circuit. The voltage concept is based on the work done when a one-way current flows through an electrical circuit. The potential difference between 2 points in a circuit is equal to the product of the resistance and the current flowing through that circuit. If a battery with voltage V is connected to a resistor, then V equals IR. A battery's potential difference can be measured. Voltage is the difference in electrical potential between 2 points in an electrical circuit. The voltage at any point in the circuit can be calculated by multiplying the current flowing through it by its resistance. Voltage difference. Voltage is the difference in electric potential between 2 points in an electrical circuit. Voltage can be measured in volts. The voltage created by a battery is measured in volts. If a light bulb is connected to a 12-volt battery, its voltage to the circuit will be 12 volts. If two batteries are connected in parallel, then the total voltage across both batteries would be equal to twice the input voltage. In other words, if each battery provided 6 volts to the circuit, then the total voltage across both batteries would be 12 volts. Conductance is a measure of the ability of a material to conduct electric current. It is defined as the reciprocal of resistance or ohms multiplied by the current in amperes. Conductance is measured in Siemens per amp. The voltage difference is the voltage of each side of a circuit. The voltage difference between 2 points in a circuit is 0 when they are directly connected and positive when one point has a higher voltage than the other. The potential difference between 2 points in an electrical circuit. Electron current velocity. Electric current velocity is the measurement of the speed at which electric charge flows through a conductor. Electric current velocity is the measurement of the speed at which electric charge flows through a conductor. Electric current velocity can be calculated by multiplying the electric field strength and length of the wire. Electric current velocities are measured in units called amps per meter. In C units, it is measured in amperes per meter. Current concept. Electricity is the current that flows from a power plant to a consumer. It is used to make things work, such as lights, computers, and refrigerators. A power plant produces electricity from the heat in a fire. The electricity is used to run an engine that turns a generator and makes the electric current. The fire is contained in a furnace that burns coal or natural gas. Coal has more heat than natural gas and creates more electricity. The current of electricity is measured in amperes. In North America and Europe, it ranges from 0.5-28 In China, it ranges from 0-50A. The amperes of current that flow through a resistor vary according to the resistance of the resistor. In North America and Europe, it ranges from 101,000 am. In China, it ranges from 10,000 am. Resistance of the circuit. The resistor limits voltage by providing opposition to electric current. Resistance of the circuit is the tendency of a conductor to offer more resistance when it is placed in an electric field. The resistance of a conductor can be expressed as the resistance in ohms. R measures how much opposition there is to the flow of electrons through a material. Resistance can be calculated by dividing current in amperes by voltage in volts. Resistance can also be calculated by multiplying current and voltage or dividing current and multiplying voltage. The lower the resistance, the easier it is for electricity to flow through that material. Resistance is the opposition to motion or change, especially when encountered by force. Resistance can be expressed as a ratio of voltage to current, and it may be measured in ohms, kiloohms, or megohms. The term resistance was first used by Michael Faraday in 1831. It is an exciting scientific concept and the opposite of the electrical current that flows from a positive to a negative terminal. This term has been used today in many different contexts, such as in physics, chemistry, mathematics, engineering, and electronics. Circuit meaning. Circuit meaning is a term that refers to how electricity flows through an electrical circuit. The word circuit comes from the Latin circulus, which means circle. A circuit is a closed loop of conductive material, usually with an insulating material, such as rubber or plastic, between the two. The flow of electrical current can be either direct or alternating. Electricity flows through an electrical circuit. Ampere and circuits. Ampere is a unit of measurement of electrical current. A unit defines the maximum amount of charge that 1 coulomb will move in 1 second. Circuits are simple electrical components that allow electricity to flow through them. They are used for different lighting, heating, and the internet. Circuits can be divided into two categories: resistive circuits and conductive circuits. Resistive circuits use devices called resistors to limit the flow of current, while conductive circuits use devices called capacitors to regulate current flow. Analog input sketch from the Arduino application. Circuit diagram symbols. Circuit diagrams are used in electronics and electrical engineering. They are also used in other fields like robotics, automotive, and aerospace engineering. Circuit diagrams are often used to teach or learn about electronics and electrical engineering. Some circuit diagrams can be found in textbooks, while others can be found on the internet. Circuit diagrams have many uses across different disciplines, but they are most commonly used to teach and learn about electronics and electrical engineering. Electronic projects. Electronic projects are becoming more and more popular as the world becomes digitalized. With the rise of technology, it is easier to have a product or service delivered in a short time. However, it also means that we are constantly bombarded with distractions from electronic devices like smartphones, laptops, and tablets. The use of AI writing assistants can help content writers overcome this issue. The assistants can help them generate content for their electronic projects without getting distracted by the devices in front of them. Arduino Projects. Arduino is a popular platform that allows users to create interactive objects. It's also an excellent way to learn about electronics, programming, and engineering. Arduino projects are also available in many forms, such as DIY kits, shields, and even ready-made boards. Arduino projects can be building your robot to make a music player or even a mood light, drones, home automation systems, games, and power tools. There are many Arduino projects that you can do yourself. Here is a list of the considerable interesting and creative ones you can try. Arduino projects. 1. DIY USB Powered Lightbulbs. 2. USB Powered Fan. 3. DIY Air Conditioner. 4. DIY LED Desk Lamp. 5. DIY Arduino Controlled Robotic Arm.